Now, what I want you to formally learn out of this discussion is solution to an equation of this kind: ax squared plus bx plus c equal to 0. I want you to learn the solution to this equation, where a, b, c are numbers or quantities whose value will not depend on x. I want you to be able to solve for x. Now, the first thing that I want to mention to you is that the credit to a formal solution to this equation, which is a quadratic equation in x, goes to Shreedharacharya. 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 The formal solution to this equation involves expressing this entity ax square plus bx plus c as sum or difference of two squares first, right? Let's see how to express this as sum or difference of two squares. Say ax squared plus bx plus c. Let me just deal with this expression to begin with. We'll talk of the equation later on. Let's understand this expression first. Now, this expression is like, could be written as a into x square plus b by a into x plus c. Yes or no? I'm seeking to express this as sum or difference of two squares. Now, this could further be written as a into x plus 2 into b by 2a. I hope you realize whatever I have done. Multiplied and divided by 2, both numerator and denominator here, right? And then it's like x square plus 2ab, isn't it? X square plus 2ab plus b square. This is my b by 2a. B by 2a whole square plus c. Now, you realize whatever I did here? X square plus y square plus 2xy. This then turns out to be a perfect square? Yes or no? This quantity. I have added b by 2a whole squared in the parenthesis here so that this is rendered a perfect square, right? So, x square plus 2xy plus y squared. Now, in the process, I have brought from outside a term b by 2a whole squared into a. Yes or no? This term was not there. B by 2a whole squared into a was never a term that belonged to this. So I brought it from outside. B by 2a whole squared into a. I must therefore dispense this term or flush this term out of the system because it never belonged to the system. The manner in which I could flush this out is I subtract this. Whatever I've added, a into b by 2a whole squared, I subtract a into b by 2a whole square. Yes or no? Right? This then is like a into x plus b by 2a whole square, isn't it? X square plus y squared plus 2xy. So x plus y whole squared, and then plus c minus a into b squared by 4a squared. A into b squared by 4a squared, yes or no? B by 2a whole squared is b squared by 4a squared, which then becomes a into x plus b by 2a whole squared. And then realize that a square appears in the denominator here, a appears in the numerator here. I can cancel this off, right? Yes or no? This then is like plus, if I add these two terms, it's going to be 4ac minus b squared. By 4a? Yes or no? Which means we have been able to express this as sum of two squares. Now, how is it sum of two squares? This I could have written as a into x plus b by 2a whole square plus 4ac minus b squared by 4a. Right? And when I write this in this form, have I created an equation? No. This equal to this is only an identity. This equal to this is only an identity. Right? Which means now this equal to 0 tantamounts to this equal to 0. Right? So essentially when I'm seeking to solve for x, I'm equating ax square plus bx plus c, or in other words, this equal to 0. This is what I'm trying to do, right? Which I can further write as a into x plus b by 2a whole square equal to, now when I transpose this on the right hand side, please understand that this would become b squared minus 4ac by 4a. This is what happens, right? The sign of this will change. B squared minus 4ac by 4a. Clear? What you could then do is, I'm assuming that a is not 0. In my attempt to solve this quadratic, I'm assuming that a is not equal to 0. Right? And then what I could do is, I could bring this a down here. So this would become 4a squared. Clear? Which would then reduce to, on extracting the square root, I end up getting x plus b by 2a whole square equal to plus minus root b squared minus 4ac by 2a. Is that all right? Extracting the square root. When I extract the square root of this, this will become x plus b by 2a, and this would become plus minus root b square minus 4ac by 2a, right? Which would mean x would be, on transposing this on the right hand side, 2a is the LCM, I get minus b plus minus root b squared minus 4ac by 2a. These are the values of x that you would obtain when you solve this quadratic in x, and we have assumed that a is not equal to 0. Clear? Now, this then is the Shreedharacharya method of solving this quadratic. Very clearly, the solution to this equation is x equal to minus b plus minus root b squared minus 4ac by 2a. Right? So if I took the plus sign, I get one root. One value of x can be x1, say. One value of x can be x1, which is minus b. On taking, let's say, the plus sign, plus root b squared minus 4ac by 2a. The other value of x can be obtained by taking the minus sign. x2 could be minus b minus root b squared minus 4ac by 2a. Yes or no? These are the two values of x obtained from this quadratic in x. Right? This is called the Shreedharacharya method of solving the quadratic. This is the formula obtained by Shreedharacharya by expressing this as sum or difference of two squares. Yes or no? So, which really means the two values of x obtained are from this. Let's say, for example, if you want to solve 2x squared minus 3x minus 1 equal to 0, for example. This is a quadratic you want to solve using Shreedharacharya. In this case, a is 2, b is minus 3, and c is minus 1. Right? The solution to this quadratic is going to be the two roots, the two values of x that will satisfy this equation would be given by x equal to minus b. Minus b means minus of minus 3. 3 plus minus root b square means minus 3 square minus 4 times a. A is 2, into C, which is minus 1, divided by 2A. 2A means 4. Yes or no? Do you all understand this? So this would reduce to, very clearly if you solve this, this will turn out to be x equal to 3 plus minus root. This is 9 plus 8, which is 17 by 2a, which is 4. So the two values of x are, on taking the plus sign, 3 plus root 17 by 4 is one value of x that will satisfy this equation. The other value of x that will satisfy this equation would be 3 minus root 17 by 4. All right? So this essentially, formulated by Shreedharacharya, is called the Shreedharacharya method of solving the quadratic. A very well-known result. We use this time and again and again. Thank you very much.